Hello. Hopefully you can all hear me. Sound. Let's see, we got 6. I'll probably give another minute or two to see if anyone else joins. And then we'll get started. I've gone through and your practice exams that you wrote. And hello, Pablo. Anyone else here? Xander here. Hey. Hello, Claudio. All right. The sound is bad, huh, Shiva? All right. Let me maybe try to work on sound. You don't wear your headphones. I found some headphones. Let's see if that makes it sound a little better. And then we will get started. Did that make the sound any better? Hopefully. Or it could just be my connection to my house. Well, that's, yeah, like seems to be loading and reloading constantly on my end. Is that happening for you guys? Yeah. No good. Oh, the sound is better? Okay. Well, that makes it sound better. Let's get started. Sweet. Glad to hear it. Yes, Lorenzo, you are back in everything from the last 3 months in 1 hour. So let's see. Shiva and Hazel wrote the first question. The standard was on using special triangles to find values on the unit circle. And the question says the points that are formed by special right triangles have been plotted on the circle. So I know that this first angle is 30 degrees. I know that the ratio is given by root 3 to x to, or sorry, 1 to 2 to root 3. So if I know that the hypotenuse is 1, then this must be 1/2. This must be root 3 over 2. So this point is created by going over 2 and by the same logic with the 45, 45, 90 triangle. I've got root 2 over 2, root 2 over 2, and 1/2 root 3 over 2. Of course, this point is 0, and this is 0, 1. Then now I'm moving left, so I've got negative 1/2, same height, root 3 over 2, negative root 2 over 2, root 2 over 2, and negative root 3 over 2, 1/2. Over here is negative 1, 0. Here I've got negative root 3 over 2, 1/2, negative 1/2, negative root 2 over 2, negative root 2 over 2, and negative 1/2, negative root 3 over 2. This spot is 0, negative 1. Here, half, negative over 2, root 2 over 2, negative root 2 over 2, and root 3 over 2, negative 1/2. Hi, Cynthia. Glad you're here. It sounds like the sound is cutting in and out. Is that true for you, Pablo? My whole video is like cutting in and out weirdly on when I'm trying to watch as if I were you guys. It's seeming like we're having issues just with bandwidth. I'm gonna try switching to lower resolution and see if that helps. Uh-oh, I switched off my screen share. Sorry, buddy. Okay. The video is stopping. Vanessa says I'm glitching. Pablo says I agree. The bandwidth. So hopefully that is going to help a little bit. Well, Lindy, I'm not talking right at the very moment. Just this, but you can't hear anything. Shivers isn't playing at all. Can't hear anything. Okay. Um, well, I think it's like, yeah, we're definitely having a test. You have a practice exam. You guys can do it yourselves. I can go, but we're definitely having a test. Anyway, number one. So I'm gonna move on. Maybe in the when the video loads afterwards, so it'll play at a better resolution. So maybe it's still useful that I go through everything. Um, but you don't get any live help. No problem. Number two, Pablo and Arandira wrote this problem. They said sketch a graph of y equals tangent of x, and then sketch another graph of y equals cotangent of x. Uh-oh. It turned close. Okay. And thanks, Lindy. Appreciate it. Okay, so it sounds like at least I came up. There's supposed to be a black screen. No, there's not supposed to be a black screen. That's clearly not correct. Um, seems like maybe it's working pretty well for some of you, depending on your internet connections. Clearly, my connection is not very good tonight. Um, but I'm gonna keep going. I think I am back up now. Um, Claudia can hear. Good to hear, Claudia. At least one of you. Alrighty, so let's sketch a graph of y equals tangent of x, and then another one of y equals cotangent of x over at least one period, and then we'll explain the relationship between the two. So let's give ourselves a y-axis and an x-axis. And I'm going to go ahead and say, well, I only need to scale over one period. So I'm going to count by, here's pi over 4, and here's pi over 2, and here's 3 pi over 4, and there's pi, negative pi over 2, negative pi over 4, negative, sorry, pi over 4, pi over 2, negative 3 pi over 4. And yeah, all right, sounds like it's working well now. Cool, good to hear. I'm going to scale. Here's 1 and 2, 3, 4, negative 1, negative 2, negative 3. And I'm going to do the tangent graph in red, and I'll do the cotangent graph when I get to it in purple. And in red, I'm going to say, let's just make an XY table. And I'll do negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Okay, at negative pi over 2, the coordinate on the unit circle is 0, negative 1. The tangent function is the y opposite on the unit circle divided by the x adjacent on the unit circle. So undefined, because you cannot divide by 0. And it looks like I'm cut out again. Yes, you get to have a page of notes on the test. Correct. One page, back and front, only in handwritten, 8.5 by 11 inches. You cannot do anything to add to or extend the page of notes. So no post-it notes, no extra stickers, no pages behind the pages. 8.5 by 11, handwritten in your handwriting. Both sides is fine. Vanessa says, how many questions are on the test? She's asking for a friend, not because she actually cares. I think the core test has 6 questions and the extended test has 7. So if you did both, that would be 13 total questions. If you only did one, then it would either be just 6 or just 7. Cool. Negative pi over 4. Here I'm at negative 1 on the tangent graph, 0, 1, undefined. So plotting those points, I'm at negative 1, 0, and 1. And I know I have an asymptote, so I'm coming up from this asymptote, and it looks like that. Good, and I got the same thing happening here. Negative 3 pi over 4 would be at 1 and coming up. And over here, we're going to be there at negative 1 and coming down and up. Cool. So there's my tangent curve. Then my cotangent curve. So this is for y equals tan x. Now, let's check out y equals cotangent of x. So x, y, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, same values. Now, cotangent is the x-coordinate on the unit circle divided by the y-coordinate. So at 0, there's an asymptote. It's division by 0. That's undefined. And at negative pi over 2, we're at 0. And at pi over 2, we're at 0. So here and here. And then at negative pi over 4, I'm at negative 1, same value. And at pi over 4, I'm at positive 1, same value. So let's see. I should have a graph that's looking something like, oh, This is incorrect. This should be more like there. There we go. Graph is at the same point there and the same point there. And we're coming down from an asymptote over there. So it's looking like that. And then there, my graph, and there, and there. And looking like that. So there's the cotangent of x curve in purple. And let's see. We know that every value on y equals cotangent of x is the reciprocal of the value on y equals tangent of x. So explain the relationship between the two, and let's put some coordinates in here. So I've got negative 3 pi over 4 comma 1, and this is negative pi over 4 comma negative 1, and here's pi over 4 comma 1, and 3 pi over 4 comma negative 1, and then the points that are only on this curve, I've got negative pi over 2 comma 0, and pi over 2 comma 0, and then over here I've got 0 0 and pi 0. Okay, great question, Pablo. That's why it's so much fun. There it is. We sketched a graph of y equals tangent of x, and then we sketched another graph of y equals cotangent of x. We have at least one period for both curves. We've explained the relationship between the two, and we did not forget to label coordinates on the functions. There was number 2 by Pablo and Arandira. Okay, then this says coal. Clearly I misspelled that. I'm not sure who wrote this question. Maybe, I don't know how that typo occurred. But someone wrote a great question. The distance between a wall and a pendulum. So let's draw a little diagram. Wall and pendulum, which is swinging, right? Back and forth. Pendulum. Shoop, 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 shoop. So there's a drawing. Here it is in purple at its average distance from the wall, which is a useful thing. And here it is again at its furthest distance from the wall. So this is furthest from the wall. Oh, this is Tom. Tom. Thank you, Tom. From wall, and here's average distance from wall. Great. Okay, we know that at t equals 0.6, the pendulum is at the average distance from the wall, which is 5 centimeters. So I know that the point 0.6 comma 5 needs to be on my curve, and this point should be on the midline. On the midline, because that's the average distance from the wall. And then I also know that 1.2 comma 11 should be on the curve, and that this point should be a max point, because this is the farthest distance from the wall. So here, farthest distance, 1.211, that's this. And then here, 0.65 centimeters, that's this. Average, so that means it's on the midline. Yes, Shiva, this is a core standard question, and Pablo is absolutely correct. This entire test that I'm working on right now is the core standards test. Well said. So let's see. I want to ask a few questions. I'd like to know what's the period, what's the midline, and what's the amplitude. Well, the midline is really easy. That's given. That's 5. Y equals 5. The period. Well, it took me 0.6 seconds to get from a low point to a high point. I'm going to sketch a little graph here. You wouldn't need to sketch a graph necessarily, but I think it's going to be helpful for me to illustrate what I'm seeing happening so far. So here's, let's move. So here's y equals 5. Y equals 5. And here's 0.6. And here's 1.2. And here I'm on the midline at 5. And here I'm at 1.2, which took me up to 11. So far I can see my curve doing this and this. So obviously it's going to come back down and down and down. I don't know, it looks like it has to go through the wall, which is a little weird, but we'll go with it. And back up. And let's see. I can see now that my amplitude must be this difference between 5 and 11. So the amplitude must be 6 centimeters. And the period, well, the period would be this whole distance. And I know how far it is from 0.6 to 1.2. That's 0.6 seconds. So here, this must be 1.8 seconds. Here, this spot must be 2.4 seconds. And here, this spot, this must be 3 seconds. So the period from 0.6, 1.2, 2.4 seconds. 2.4 seconds. So now I can start constructing a function. And I'm going to write y equals 2.4, because I know the amplitude. It's hard to know whether I should use a cosine curve or a sine curve. But it's looking to me, if I continue this back to 0, that the easiest way is going to be with a negative cosine curve, because it starts at a low point. 0 looks like it's a low point. So I'm going to say negative 2.4 cosine of, the period is 2.4 seconds. Sorry, the amplitude was 6. My fault. That should be 6 out there. Negative 6 cosine of 2.4. So I know that the period equals 2 pi over the b value in the function. So that means that b should equal 2 pi over the period. So if the period is 2.4, I'm going to put 2 pi over 2.4, and cosine of t we'll use for time, and then the midline is 5 plus 5. There's my answer. Uh, Lorenzo, uh, some questions that weren't done at all, I just ignored or took out. Some questions that were kind of unfinished, I've edited to make so they work. Cool. So there's my answer to Tom's excellent question number 3. Um, if any of you have questions at any time about the actual math, please let me know. So far, none. That's okay. Here we go. A question from Claudia. Are the graphs of y equals sine of x and x equals sine y functions? First, graph the two relations below, and then use the graph to explain whether each is a function or not. So here, I'm going to graph y equals sine of x in red, and then I'll do x equals sine of y in blue. So in red, y equals sine of x. I've got 0. Let's see, negative. So pi over 2 is like a little less than 3. No, a little bit more than 3, sorry. A little bit less, which is past than 3. There we go. And out here, there we go. And pi and pi and 2 pi. So pi over 2 would be like kind of right up here, and down, and down, and up, and down, and up, and up, and down. And there's y equals sine of x. And I can see pretty clearly that this passes the vertical line test. Every input has exactly one output. So here in this graph, y is a function of x. Every input has exactly one output. Every input x has exactly one output y. Then let's try the graph of x equals sine of y. Well, that one looks a little different. So x equals sine of y. I've got 0, 0 is still on there. 6.2 would be a little bit up there. Here's pi right about there. Negative pi, negative 2 pi. And it's going up to, oh shoot, I went up to 2 and down to negative 2. This is all wrong. My bad. All right, let me just, no, let's change it. So it should only go up to 1. I didn't see what the scale was. 0, pi, 0, pi, 2 pi. And here we are at negative. And here we are, positive. There we go. Better. And again, still a function. Y is a function of x. And now the blue one. So I've got here and here. We're coming up and then down and up like that. And down, up like that. And here I can see as well very clearly that x is not a function of y. X is not a function of, sorry, y is not a function of x. Is not a function of x. Inputs in x have infinitely many outputs in y. Cool. There we go. That was number 4 by Claudia. Okay. Next up, we have number 5 by Xander and Lindy. Don't look, Xander. I don't know what that part means. Jimmy John decided to go to Disneyland over winter break. He decided to roll on over to the Ferris wheel right after he ate a pretzel. Jimmy John knows that the height of a rider over time on the Disneyland Ferris wheel can be modeled by the equation h equals negative 35 cosine of 15t plus 40. And he also knows that he gets dizzying sickness when he gets over 20 feet in the air and throws up. So the question is, how long will Jimmy John be on the Ferris wheel before he throws up? So let's draw a Ferris wheel. We can see that its midline is at 40 feet. 40 feet. Its radius is 35 feet. So this whole distance is 70. So he's going to get on and he'll be 5 feet high. And he wants to know how long it'll take before he gets 20 feet in the air. So when does the graph of this function, negative 35 cosine of 15t plus 40 equal 20, which is like, in terms of our scale here, not very much to scale, but clearly before the midline, this is 20. Sander says there's a hyperlink on the names. Well, I don't know how that helps me, but I believe you. Okay. So now I'm solving for t. How much time? Minus 40 minus 40. Oh, you don't want me to look at the hyperlink. I see. That makes sense. I won't look at the hyperlink. Thank you, Xander. So I've got negative 35 cosine of 15t equals negative 20. Cancel, cancel. Now I'm dividing by negative 35. So I've got cosine of 15t equals what? 4/7? I think that's right. Yes. So 15t equals the inverse cosine of 4/7. And I don't know that by heart, so Desmos. And oops. inverse cosine of 4/7. So we've got 0.96. We're going to assume this is in degrees, I think. That makes more sense. So 15t equals 55.15 seconds. And divide by 15. And sounds like I will be throwing up after 3.68 seconds. T equals 3.68. Maybe that would make more sense in minutes, really. Let's try minutes. 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 Okay. So, Jimmy John will throw up 3.68 minutes after the ride starts. Bam. Cool. So it looks like H in feet, T in minutes on that one. Cool. Great question again. I don't think anyone's actually asked a math question yet tonight, but that's okay. Maybe there will be one later or tomorrow or something. This is the last one on the core standards test. It says, label the triangles below to prove the Pythagorean identity, and then use sine of theta equals 1/2 to find cosine theta and tangent of theta. And this problem was written by Ivan and Nancy. So I can say, here's theta. If I make this 1, then this is the cosine of theta, and this is the sine of theta. So since a squared plus b squared equals c squared, that means that sine squared theta plus cosine squared theta must equal 1. QED. Cool. Now, if sine of theta equals 1/2, I have to find cosine theta and tangent theta. Well, obviously, I already know that if sine of theta equals 1/2, that I'm on 30 degrees on the unit circle. So this is pretty quick. So here's theta. Sine of theta is 1/2. I could actually do the work and not have it memorized. So let's go ahead and plug this in. I know even if I don't have this memorized, let's do the work to plug this in, because I think on your test it's not going to be a 30, 60, 91. Lorenzo says there's no questions because you understand everything. I love that answer. That's great, Lorenzo. So then I'd get 1/2 squared plus cosine squared theta equals 1. So 1/4 plus cosine squared theta equals 1. So cosine squared theta equals 3/4. So cosine theta equals root 3 over 2. Root 3 over 2. And 1. And tangent of theta. Well, the tangent of theta equals the sine of theta over the cosine of theta. So the tangent of theta equals 1/2 over root 3 over 2, which equals 1/2 times 2 over root 3, which equals 1 over root 3, which when I times by root 3 over root 3 gives me root 3 over 3. Okay, those are the core standards. Any questions on the whole core standards test? Okay, cool. On to the extended standards. This one by Renee and Sergio. Lorenzo says, are these the only type of problems that are going to be on the core standards test? Um, well, I mean, those 6 standards are the core standards for this uh, quarter. So, I mean, the questions will be similar. Like, some things have some variety, but this is really straightforward. Prove the Pythagorean identity. There's not a lot of, and then find sine and cosine or tangent given the sine, cosine, and tangent. Like, this problem, number 6, has to look pretty similar to this problem. Um, let's see. This is just about solving a trig equation, and it's got to be a word problem. So I'm going to give you a trig equation in a word problem form, and you have to solve for the input. So this will be something similar. I mean, it might not be like Disneyland and a Ferris wheel. It could be a pendulum. It could be something else. It could be light, temperature on Earth, lots of things. But it's going to be a word problem that you have to solve. This one, it's going to be about the domains of the trig functions. I mean, this one, you've done a lot of practice with these. Choose trig functions to model situations. Graph all 6 is pretty basic. And then the unit circle. I mean, yeah, there's not a lot of variety here, Lorenzo. They're going to be similar to these. Maybe not exactly those problems. Maybe not. It could be like the trig scenarios could be different, but the same types of problems. Anyway, I'm going to go on to the extended standards. Here we have Renee and Sujir's problem. Use the unit circle to explain why cosine of theta equals cosine of negative theta. So, cosine values on the unit circle are the x values. Like here and here. Or here and here. The x values are symmetric. About the x-axis. Good night, Vanessa. Sorry you couldn't stay up this late. Let's see. Clearly, Xander, you should use germ-DOS sad Mr. Egg. If there are any radicals, you need to know that radicals are the inverse of exponents, which you wouldn't know if you were using PEMDAS. So you would fail if you use PEMDAS. About the x-axis. Since any angle traversed in the positive direction will be symmetric to symmetric. Shiva is asking a great question. Yes, I'd like you to, if you decide to do the core standards question test, I want you to do the whole core standards test. If you decide to do the extended standards test, I want you to do the entire extended standards test. So you can't cherry pick which questions you're doing. If you've met all the core standards already, you don't have to do the core standards test. But if you need to do the core standards test, I want you to do the entire core standards test. Positive direction will be symmetric to the angle in the negative direction about the x-axis. The cosine of any angle is equal to the cosine of the negative angle. Cool. So that was a lot of writing. You wouldn't necessarily have had to written all of that. The key idea here is that we've got symmetry with respect to the x-axis. So any value here is going to be the same on the opposite side of the x-axis. Any value here, same on the opposite side of the x-axis. That's the key statement you had to get at too. Xander's asking, we can choose which test to take. Yes. If you don't need to do any better on the core standards, if your core standards grade is fine, then you don't have to take the core standards test. You could just take the extended standards test. If you do need the core standards test, you do need to show me more understanding of the core standards, then you are welcome to take both or just the core standards test. Recognize if you only take the core standards test that your best grade would be a C. Cool. That was number 1. Thank you to Renee and Sergio. I know Lorenzo was worried that Renee and Sergio's question wasn't going to be good, but it was a great question. Okay. Grace and Jocelyn asked, use the function below to graph maybe this sinusoid. What is the period, midline, and amplitude of the graph function? And their curve was 3 sine of pi x minus 5. So period, it's looking like 2 pi over pi, which equals 2. Midline at y equals negative 5. And amplitude of 3. So I'm going to go down 1, 2, 3, 4, 5. And there's the midline. And then I'm going to graph, let's see, sine of 0 is 0. 3 times 0 is 0. So here's 0, negative 5. The period is 2. So I'm going to say an entire curve would be made in 2. I'm going to extend it out a little. I'm going to say here's 0.5 and 1 and 1.5 and 2. And the same going backwards. Negative 2. Okay. And I know I'm all the way back to the beginning, to the same value when I get to 2. So I must be back at -5. Same here at 1, at -1, and at -2. Halfway in between, I'm up at the high point. Let's see, what's the high point? Up 3. 1, 2, 3. And then I'm down at the low point. 1, 2, 3. And low point, 3, 3. Here we go. All right. There is y equals 3 sine of pi x minus 5. And I identify the period, midline, and amplitude. Rad. Good stuff. Thank you, Grace and Jocelyn. Savian and Olivia wrote, use angle C to find the length of the arc AB. Find the radian measure of angle C. Describe the relationship between the radian measure of C and the length of arc AB. Okay, so let's see. Here I'm in degree mode. So to go directly from degree mode to the length of the arc, that's arc AB. I'm going to say I've got 45 degrees out of the entire 360 degrees, which is equal to x, some amount of arc, out of the entire circumference, 2 pi times 12. So this is 1/8 of x over 24 pi. So 8x equals 24 pi. So x equals 3 pi. Centimeters, units, some units. Let's say centimeters. Centimeters, centimeters. And that was A. Oh no, they didn't, they used numbers. That was part 1. Part 2, find the radian measure of angle C. Well, let's see. Radian measure, I'm going to move off to the, or maybe I'll just shrink myself down here. So that was step 1. Step 2, 45 degrees times pi over 180 equals, let's see, 45 degrees and 180, we're talking about a quarter. So pi over 4 radians. 3. Describe the relationship between the radian measure of C and the length of arc AB. So we've got the radian measure of the angle is 1/12 of the arc because the radius is 12. 12 centimeters. If the radius was 1, like on the unit circle, the radian measure would equal the arc length. Cool. That was number 4. Thank you, Savia and Olivia. Then we've got Fernando, Michelle, and Alejandro. It doesn't look like they finished that question. So there's number 6 by Colin and Vanessa. Oh, we have 9 questions on the extended test. I was wrong earlier. 9 questions on the extended test. Number 6 says, below is a picture of a right triangle with a measure of angle A. John Williams knows that the sine of A is the length of the side opposite A divided by the length of the hypotenuse. Sine of A equals BC over BAC. John Williams says, the sine of an obtuse angle does not make sense because I can't make a right triangle with an obtuse angle. Draw a picture and explain how John might define the sine of an obtuse angle. So, John might independently think of the... Oh, Michelle and Michael says they did theirs. It's there. And I just didn't... I got this off the internet more than an hour ago. So my fault, Michelle. I'll go back and get it at the end if we have time. Thank you. So here's an obtuse angle, theta. And we could define the sine as being this distance. Sine of theta. Great. What are the sine of 3 pi over 4 and sine of pi? Sine of 3 pi over 4 equals root 2 over 2 because it equals the sine of pi over 4. Same thing. So root 2 over 2. Sine of pi equals sine of 0 equals 0. Okay. Sweet. There's number 6. Number 7, find an inverse function. Great. We've got 3 cosine. So y equals 3 cosine of 2x minus 1 plus 8. To find the inverse function, we're going to switch the x and the y. So x equals 3 cosine of 2y minus 1 plus 8. And we're going to solve for y. So minus 8 minus 8. I've got x minus 8 equals 3 cosine of 2y minus 1. Let's divide by 3. So x minus 8 over 3 equals cosine of 2y minus 1. Let's inverse cosine. So that 2y minus 1 equals the inverse cosine of x minus 8 over 3. Let's add 1. So that 2y equals the inverse cosine of x minus 8 over 3 plus 1. And we end with y equals the inverse cosine of x minus 8 over 3 plus 1 all over 2. Or y equals 1/2 inverse cosine of x minus 8 over 3 plus 1/2. Okay. That was great. Thank you to um, who had that one? Well, I don't know who had that one. Thank you to who had that one. Number 8. 1 gave us this problem. use the sine sum formula to find the sine of 7 pi over 12. So the sine of 7 pi over 12 equals the sine of 3 pi over 12 plus 4 pi over 12, which is the same as the sine of pi over 4 plus pi over 3. So that's going to equal the sine of pi over 3 times the cosine of, sorry, pi over 4 times the cosine of pi over 3 plus the cosine of pi over 4 times the sine of pi over 3, which is root 2 over 2 times cosine of pi over 3 is 1/2 plus root 2 over 2 times the sine over 3 is root 3 over 2 equals root 2 over 4 plus root 6 over 4 equals root 2 plus root 6 all over 4. Okay. Number 9, we have Veronica and Steven's problem, which I'm going to try to make a little more visible. Ungroup, shrink that down so it fits in there. There we go. Veronica and Steven's problem. The sine and cosine functions have the same domain and range. Why is the range of y equals inverse sine different from the domain of y equals inverse cosine? Great question. So we're going to say here's negative pi over 2, pi over 2, and let's do sine in blue. Pi. Oh, pi. Okay. To form an inverse function, or let's see, let's write it this way. For a function to be invertible, Xander, all of quarter 2. The final is on all of quarter 2. So the last, which was kind of one big unit. We didn't take a unit 3 test partway through. We just had quizzes. But yeah, the first unit 3 was supposed to be about graphing and sine and cosine and the trig functions. And then unit 4, which kind of got shrunk and diminished a little bit and plugged in at the end of unit 3, was on solving the trig functions and using identities. For a function to be invertible, every output must have one input. Let's see. Y equals sine of x is invertible on negative pi over 2 to pi over 2. So from here to here, this is invertible. It passes the horizontal line test. But y equals cosine of x is not. Y equals cosine of x is invertible on 0 pi from here to here. It passes the horizontal line test. Since we use different domain restrictions, the inverse functions have different ranges. Rad. There it is. Thank you, Veronica and Steven. Since Michelle mentioned it, why don't we see if we can grab her question now that it's been updated. So File, Google Drive, the extended. Let's reload it in the Google Drive because I think that's just going to keep the same one that I had before. 1819, Trig Calc, handouts, extended. Michelle. Hey, I love it. It looks great. Zy is the diameter of circle P. The length of PY is 10 units. What will the exact length of ZXY, the arc, be? Great. So here's Michelle's questions. I'd be happy to do that, Shiva. I will update the outline document since I didn't include a lot of the extended standards. Yes, that's a brilliant plan. It was an ambitious document, and I'll update it to what we actually covered. So, figure that zy is the diameter. The length of py is 10 units. I think we're talking about arc zxy. So it looks like it'll be half the circumference because that's a diameter. So arc zxy will equal 10 pi. Thank you, Michelle. So I had a request from Shiva, update the outline document. Other questions, requests, anything of the sort? If not, I think we're done. Sorry about the technical difficulties at the beginning. I'm glad it seemed like at least it was working for everybody later on. You could, in class tomorrow, Shiva, you could be working on Khan Academy or working on this practice exam, making sure you know how to do all the problems, or working on your page of notes. Those are all opportunities you have. Anything else for tonight? Okay. Seeing none, I will see you all tomorrow. See you tomorrow, Claudia. Have a good night. And then good luck on your final exams Tuesday. No problem, Michelle. Good night, Lindy.